So, good evening, Triveni, and is all concepts are clear what we have discussed till now? Once confirmed.
Yeah, sir, clear, sir.
Yes, so, I'll share the screen and I'll tell you one application that you try to do it. Can you print the size of an integer number? Once check if you can print it. You can share your screen. I have given permission. Okay, just print size of an integer variable as well as print size of character variable also. Print size of one character variable. Declare one character variable and print its size. Okay, once run it. Once check why the output is not printed. See, you are printing on integer number, but you can see you are not using this percentage D actually in the printf statement. Yeah, percentage D comma you can put. Right. Okay, now you can print this. So if you use /n, then you'll understand clearly. Okay, 4 bytes and 1 byte. Now what you do is you declare one integer pointer and character pointer, like ptr1 integer pointer or p1 integer pointer, p2 character pointer. Assign the address of integer variable to pointer 1. Assign the address of character variable to pointer 2. You have to declare it first. Right. ptr1. See, in ptr1 you want to store address of integer number. Okay, fine. But in ptr2 you want to store the address of character. So the data type of ptr2 should be of character only. Why? Because you are declaring the pointer variable to hold the address of a character variable. So line number 6, integer PTR1 is correct, but PTR2 should be of character type. Right. So now without first you print the size of pointer 1 and pointer 2. You write the print statement to print size of pointer 1 and pointer 2. And before running this program, before executing the program, you just guess the output and you just write it there, like what will be the size of pointer 1 and pointer 2. Very good. See, it is not percentage u, because you are not printing the address, you are printing how many bytes that address variable is going to occupy. So it's percentage d only. So yeah, this is PTR2. Can you put a comment at line number 12 and 13 beside that, and can you write how many bytes it occupies? You guess and write it. How many bytes both PTR1 and PTR2 are going to occupy? 4 bytes, okay. 1 byte, okay. So now you can run the program and check it out whether you are getting 4, 1 or not. Four, 1, just once close this program and show me. Okay. So PTR1, you are assigning, see PTR1, PTR not 2 are not taken as pointer variables because you are not used as star symbol at the time of declaration. They are considered as ordinary variables only. Yeah, now they are considered as pointer variables. So now you see the output ones. So you won't get like 4, 4. You are getting like 8, 8. Is this clear? So here, do you have any other IDE? Like this is Dev C++. Do you have like code blocks? So same program, you copy, paste it in code blocks and try it once if you have.
Code blocks is not working in my
It's not
laptop.
working. Okay, fine. So you do one thing, you can stop sharing the screen and I'll show you on my machine because I have code block installed. I'll show you in code blocks what kind of output you will get it. So I'll declare one variable called number whose value is 10, and I'll declare one pointer variable p1, character C. I'll assign some character A to it, and I'll say star p2 p2. Okay, now I'll say p1 equals to ampersand of number, and p2 equals to ampersand of C. So we know that integer occupies 4 bytes and character occupies 1 byte. But now I want to display what is the size of P1 as well as size of P2 both. And you'll be surprised to see both are getting like 8 bytes only. Is it clear? So actually, though you are declaring, and same program I'll show it on another machine means another ID. I'll use C3 ID, and here you'll see you'll get 4 bytes. You'll see 4 bytes. So whenever this kind of questions comes in interview, we have to answer so smartly, because if you have experience of working on different IDs, then definitely you'll understand that we are getting different answers. First of all, you won't get like 1 and 4. The reason is here. Let's try to understand how many bytes a pointer variable is going to occupy. So for understanding of this, you need to understand this. Suppose if you declare one variable of integer type n, and you declare pointer variable p1. So for n, actually what happens, 4 bytes will be reserved. But once you assign the address of this n variable to a pointer variable p1, then only the base address will be stored actually. Okay, 203, this one. And when you take double, 8 bytes will be allocated for this. Only the base address will be stored. And even when you are working on a character type, only 1 byte is reserved, but this address will be assigned to one pointer variable, that is P3. But when you look at it, the pointer variables are going to hold the memory addresses, and memory addresses are nothing but some whole numbers. They are nothing but some whole numbers. So pointer variable of any data type, you just take it. It occupies either 4 bytes or 8 bytes based upon the ID what you are using. Based upon the ID what you are using. So for better understanding, I'll say pointer variable of any type occupies 4 bytes or 8 bytes. So it depends upon the type of compiler what you are using. See, pointer in C is just a variable that could store the address of other variables. In C, size of pointer variable is not fixed, as it depends upon the word size of the processor. So in general 32-bit machine, then the size of a pointer would be 4 bytes, while on a 64-bit machine, it would be 8 bytes. So you can see here. So when you work on a 16-bit processor, it will be 2 bytes. 32-bit processor, it is 4 bytes. 64-bit processor, 8 bytes. So here what happens, like when you are using like dev C++ code blocks, you are getting like 8 bytes, because your operating system as well as the software, the ID what you are using is actually designed for the 64-bit processor. That is the reason it occupies 8 bytes. But whereas in C-free ID, I have shown you, C-free ID is works also on a 32-bit processor also. That is the reason we are getting like 4 on C-free ID. So this is how you need to answer actually, that it is 4 bytes or 8 bytes. It depends upon the type of the processor on which your application is running. So is this clear? And do you think that this is something important information you got today? So pointer variable of any data type you take it, it occupies either 4 bytes or 8 bytes of space in the main memory. See, character occupies 1 byte, but whereas character pointer occupies 4 bytes or 8 bytes, because pointer variable holds only the number but not the data actually. Okay. And there is a concept of double pointer. Double pointer means you store address of one pointer variable inside another pointer variable. Then you have to declare like a double pointer actually. So here P1 stores address of X, but whereas P2 stores the address of P1 itself actually. So P2 is declared as a double pointer. So is this clear, Triveni? Up to this, is this clear?
Yeah, sir, clear, sir.
Now, we need to understand what is memory allocation and how many types of memory allocations are there. There are two types. One is static, which is also known as compile time. Second one is dynamic, which is also known as runtime. So, whenever you declare a variable or an array, then the size is fixed based upon the data type what you are using. But if you are developing real life applications, you cannot ask your client that, hey, tell me how many admissions you are going to take. We'll allocate memory that much. It is not possible actually. We cannot ask any client in advance saying that, hey, tell me how much space you want to reserve for your application. As and when the program is growing, the memory should be allocated at runtime actually. So we need to understand what is dynamic memory allocation. But before that, we need to understand the memory structure also. So as per the programming language, the memory structure is divided into 4 types: text segment, global variable segment, stack, as well as the heap. So whenever you write a piece of code, like you can see, I've written a program. So all the code, all the instructions of the program will be stored in the text segment. And what are the global variables you declare? All those global variables will be declared inside the global variable sections. And all the local variables as well as the functions will be stored inside the stack memory. And heap is the memory area, which is nothing but large pool of free memory. And if your program requires memory at runtime, then your program will access memory from the heap actually. It will access memory from the heap. So that's where the concept of dynamic memory allocation will come into picture. So to take the memory at runtime, to read the memory dynamically at runtime, we need to work with dynamic memory allocation functions. So there are two main important functions. One is malloc and second one is free actually. Malloc is used to allocate the memory and free is used to remove the memory. So let's try to understand how we can write a small program for understanding of malloc as well as realloc as well as free in one small piece of code. I'll show you the code which is already written in order to save the time. So you can see here, I'm asking the user like how many numbers you want to read. So I'm not declaring any array in advance. I'm not declaring any array in advance. I'm asking the user like how many numbers you want to read. If the user says that he wants to read like 10 numbers, then what I do is I allocate the memory by using malloc function saying size of n. Like what is the size of your n? If it is 4 bytes, then into n value is 10, for example, if you want to read 10 numbers, then totally 40 bytes of memory will be reserved. And by default, malloc function returns void pointer. But here I want to store integer number, so I'm typecasting it to integer pointer. This is known as typecasting. And now simple, using for loop, you can read. Don't use ampersand because you are not storing data in an ordinary variable. you are assigning data directly to the memory address actually. So you have to use P, and every time the memory address has to be incremented. So plus I. Now you can print that data. Now later if you feel that the memory is not sufficient and you want to increase it, then you can use a function called realloc, and you can tell like for which pointer variable you want to increase the memory, and you can specify the new size actually. The new size I'm saying n plus 2 means existing n plus 2 more numbers I want to store. And simply you can run this program. And after that, you can use the free function to remove the memory. So we have worked with three functions here. malloc for allocating the memory, realloc for increasing the memory, free for releasing the memory. So suppose I'll say I want to read three numbers. You can read three numbers, and after that you will see you'll get like three numbers first, realloc, and you'll get three numbers, and later two more space for the two more numbers is allocated. We have not assigned any value to it, so that's why by default we are getting the garbage values in that. But you can see the whole memory addresses are in the consecutive locations 112, 16, 20, 24, and 28. So you may ask me like why we need to work with these dynamic memory allocation functions. So you should work with dynamic memory allocation functions, because in future, if you want to practice data structures and algorithms, then working with dynamic memory allocation is the first concept of your data structures. There is one more function called CLOC. Let's try to understand what is the use of CLOC. So here, the difference between CLOC and MLOC is, in CLOC, you have to specify like how many numbers you want to store and what is the size of each number actually. And what it will do is it will allocate the memory in chunks actually. So if you see, it is similar to MLOC only, but there is small difference. So the difference you just try to understand it here. So first thing in MLOC, all the data, if you do not initialize, by default they will have garbage values, whereas in CLOC the data will have zeros by default. Okay, that is one main difference actually. That is main difference. The other differences is like we need to split and pass the memory as we want in CLOC. In MLOC, we can say like how much memory we want actually. Like you can say 40 bytes. Like this you can say here. CLOC size 5 comma size of int. MLOC here you have to say 5 into size of int. So here you just try to understand the difference between these two. In CLOC you are saying, in CLOC you are specifying the major difference, I'll tell you. So in CLOC, what happens, you know, CLOC, you will say 5 numbers. Each number occupies 4 bytes of space. And all the data will be by default initialized with 0. In MLOC, you specify you need 5 numbers. Each number occupies 4 bytes. That's nothing, but instead of writing like this, what you can do is you can simply say 20. And the data will be, if you do not initialize, by default, the data elements will be initialized with garbage values. Okay. So in this case, in CLOC, you have to pass two parameters actually. How much of data you want to reserve and what is the size of each data. But whereas here you can say, like, I want to reserve 20 bytes of space. So in MLOC, you can specify like a total size actually. So in our program also, you can see the difference. Uh, it may look like you are passing two parameters. It may look like you are passing two parameters, but we are not passing two parameters. We are saying size of n into n. So size of n into n, actually it is only one number you are passing. For example, if you set 10 numbers, each number occupies 4 bytes, then actually you are passing 40 here. You're passing 40. But whereas in CLOC, you're specifying how many numbers, how many bytes each number. So there is difference in passing, okay, and there is difference in initialization. CLOC by default, all the data will be initialized to zeros if you do not assign it. That's what the difference is. So is this clear actually? Triveni got clarity on this? MLOC and CLOC, free realloc.
Yeah, sir, clear, sir.
Okay. Now there is one more small topic related to pre-processor directives. We'll see that. And then tomorrow I'll start working with structures and unions actually. See, you are aware of only one pre-processor directive, that is hash include actually. That is hash include. So you need to understand what is pre-processor. Pre-processor indicates before processing, before your program execution is done. So what is done is, you might be writing a program having extension as .c, hash followed by some statements, and this will be your source code. Pre-processor is a special program. Pre-processor is a special program. What this program will do, it will create one intermediary file. It will create one intermediary file by including these header files into your source code with the extension .i, that we are unaware of that actually, because that is directly passed to the compiler by this preprocessor program. And the compiler produces .o file, that we are aware of that. And then the library functions definitions are included, and exe file is generated. This is we call actually build. Even when you are working with your dev C++ ID, you will see like build. So the meaning of build is executable file will be created actually. That's what actually build is. So there are four types of preprocessor directives are there: macro substitutions, file inclusive, conditional compilation, and miscellaneous. So file inclusive is nothing but hash include that we have seen. Macro substitution is nothing but, suppose you are writing a program where you want to calculate area of circle. So what you can do is, instead of using pi value as 3.14, what you can do is, you can say define pi, and you can say 3.14 actually. Sir, if I use like this and if I declare one variable, so what is the difference actually? If you use variable, then what happens, at runtime only the value of the variable will be taken into consideration. But whereas when you define a macro, then before pre-processing, wherever pi is written, the values will be replaced with 3.14. And it is said that if anything is done before the compilation, then automatically the program execution will be improved actually. This is what we call simple macro actually. Is it clear? I have given some examples, you can check it out. Even I can show you some interesting concepts related to macros. Uh, you can observe, I have said hash define, and macro name is PF, and this represents entry number actually. So throughout your program, wherever you want to use this statement like printf entry number, what you can do, you can simply write PF. And I'm defining scanf in double quotes percentage D comma ampersand. I'm not giving variable name. Okay. So what you can do is you can declare two variables A comma B. When you say PF printf enter a number, you'll get it. When you say read, then the whole code will be replaced here. It will be replaced here, and up to ampersand, we are simply saying the variable name brackets close and semicolon, and it will generate a program like adding of two numbers, and it will look like a normal program. You can see, but we have done this program by using macros concept. This is a quite interesting programming example. You can just check it out. Actually, you can check it out. This is like one of the very interesting concept of macros. So what is the difference between macro and a constant keyword? So as I said, variable declared using constant keyword must be of some data type, but whereas macros will not have any data type. So when you have a data type, there will be a concept of typecasting, and when there is no data type, there won't be anything related to typecasting. For constant variables, memory is allocated, but whereas for macros, no memory is allocated. So when the program is occupying less memory, obviously the performance of your application will be high actually. But the variables will be passed as parameters to functions, but whereas macros cannot be passed. Variables can be global or local, but macros should be only global. Variables can have pointers, but whereas macros cannot have pointers. So like this, there are some predefined macros. You can check it out, which prints date, time. Is it clear? You can just check it out. File inclusions, I said actually, we are working. And there are some conditional compilation concepts are there. I'll show you one simple example. So here what I'm saying is I'm defining one macro with the name OS, and I'm saying it's a Windows 10 operating system. If def OS, the meaning is if the macro OS is defined, then you work with this statement. Otherwise, you work with this statement actually. So what happens, whenever you are running these particular applications on different operating systems. Imagine you are running this application on a different operating system. Then uh, the whole program should run related to that particular operating system. Then what you can do is you can simply comment this actually. Once you comment this, then automatically the program will start functioning towards a Linux operating system. So here we are specifying if the OS is defined, then you do this else. So you'll set some variables here, you set some variables here. So if operating system is Windows, then automatically that parameters and those variables will be taken into consideration. Otherwise, these parameters and these variables will be taken into consideration. So these kind of macros concepts are used when you develop an application that is working or that is created for the different types of operating systems. Same application should be designed to run on different operating system. So by doing very little change, you can make your application to be available for any kind of operating system. These are known as actually conditional directives. That's a thing. But before compilation, you are deciding how the application should get compiled, actually, towards which goal your application should get compiled. Okay, so this is about conditional compilation. And tomorrow's class, I'll explain about structures as well as unions. These are some miscellaneous topics. These may not be there in your curriculum to this deeper level, but out of my personal interest, I have included in my course so that students who wants to learn the subject at deeper level, they may go through this type of concepts. Is this clear, Triveni? Any doubts?
Yeah, sir. Clear.
Clear now? Okay. So tomorrow we'll start working with structures as well as unions concept. Okay. So thank you so much and see you tomorrow at sharp 8 p.m.